Hello, and today you're going to be looking at the area formulas for polygons and circles, as well as calculating the areas of composite figures. We did do this before the break, so I imagine this should be pretty easy for you, but it does require a lot of concentration and focus. So first of all, let's just look at the areas of 2D polygons. The two-dimensional polygons would include shapes such as rectangles, triangles, parallelograms, and trapezoids. We also have circles, but circles are technically not polygons because they are not composed of straight edges. The rectangle has an area of base times height. The rectangle, as we mentioned in the last video, is very easy to see the area because you can see that in square units, this would be 18 square units. 6 times 3, 18 square units, or 18 centimeters squared. Triangle is technically half of a rectangle. You can see that if you take the rectangle and cut it in half, you have the area of a triangle. So the formula is base times height divided by 2. In this case, 6 times 3 divided by 2, or 9 centimeters squared. Parallelogram is really just a rectangle that's been tipped over, and we use base times height. Make sure that you're not using the length of the side of the parallelogram. You have to always use the height, and the height of a parallelogram is always perpendicular to the base. Make sure that you use the line that's perpendicular to the base for the height. The area of a trapezoid is found with the formula base 1 plus base 2 times height divided by 2, because a trapezoid is technically two triangles with the same height. So we can see that we're finding base 1 times height plus divided by 2 plus base 2 times height divided by 2. And that can be simplified to be the formula mentioned above, base 1 plus base 2 times height divided by 2. The area of a circle, as reviewed from yesterday, pi r squared, or pi times r times r. A semicircle, pi r squared divided by 2, or pi times r divided by 2. That is found by just using the area of a circle and cutting it in half for a semicircle. If we're looking at composite areas, we can use addition. What it means to do a composite area is just to find the area of each of the smaller shapes within the larger shape. This case, we're going to have a triangle on the left, so to find the area of the triangle, we do base times height divided by 2. 9 times 7 divided by 2, or 31.5 units squared. The middle piece is a rectangle with a side of 3 and another side of 9. We know that the height of that rectangle is 9 because the parallelogram next to it has a side length of 9. And that is a parallelogram, so both pairs of lines are parallel. If you look at the parallelogram, we have to calculate the height. They give you the base of 9, but technically we don't know the height. So we have to look at the full length of 16 and break it into its pieces. So you can see that it's 7 plus 3 plus the height equals the 16 at the bottom. So if we solve for h, we see that the height is 6. Therefore, the area of the parallelogram is 9 times 6, or 54 units squared. The last step to find the composite area is to add together all of those areas, and we get 111.5 units squared. The second example shows composite area with subtraction. In this example, you see that we have a circle. The shaded area has a triangle that's been cut out. So to solve this one, we would first find the area of the shaded region by finding the area of the circle and subtracting the area of the triangle. The formula for area of circle is pi r squared. We would then subtract the area of a triangle, so that would be base times height divided by 2. In this picture, we can see that the base of the triangle is 16. It's also the diameter of the circle. When we look at the height of the triangle, we can see that it's equal to the radius of the circle. So the radius would be 8. The height of the triangle is 8 because the height is also the radius of the circle. Next, we would substitute the values we know. pi would be 3.14 times 8 times 8 minus the base of the triangle, which is 16, times the height, which is 8, all of that divided by 2. If we put that into our calculator, we get 200.96 minus 64, and that equals 136.96 meters squared. I'm also going to attach another video with additional examples of solving for composite area. You can open that up and view it and scroll through it if you'd like some more examples to help you with solving your quizzes. Make sure you also open up the notes attached on the areas of simple shapes so that you can use those area formulas to complete the homework. Make sure you use a calculator. If you have any questions, please let me know. Thanks.